In this video, I'll be demonstrating to you guys how to draw a Lewis structure diagram for the nitrate molecule. And to begin with, we're going to determine the total number of valence electrons in this molecule. Nitrogen has 5 valence electrons because it's in group 5A, and there's 1, which gives us a total of 5. Oxygen has 6 because it's in group 6A, and we have 3 of these, which gives us 18. And then we have 1 additional valence electron from this negative, which gives us a total of 24 valence electrons that we must use when we draw our diagram. Now, to determine the central atom, we look at the atom with the least number of valence electrons, nitrogen in this scenario, and we draw that in the middle. And then we take our oxygen and we draw 3 of these around our nitrogen. And then we draw in some bond pairs, and each bond pair is worth 2 valence electrons. However, for major group elements like nitrogen and oxygen, they must fulfill something called the octet rule, which says that atoms must have 8 valence electrons in order to have stable configuration within a molecule. Nitrogen only has 6 here, so we must draw another bond pair, which gives us 8. 24 minus 8 gives us 16 valence electrons left over that we must use. And now we can use these to fulfill the octet rule on all of the rest of these oxygens. We have 6 valence electrons used for every single bonded oxygen, and 4 for every double bonded oxygen, which gives us a total of 0. And that is our proper Lewis structure diagram. And now I've decided to bring in a 3D model to help us answer any further questions that we might have, like the polarity of our atom, the intermolecular forces, geometry, and bond angle as such. Polarity, we can see in our atom, is nonpolar because all of these atoms are equally shared and there's no uneven pulling. Nonpolar. And that means our intermolecular forces, we wouldn't have dipole or hydrogen bonding, we would just be left with our dispersion forces. Next, we can go to our geometry. And to determine our molecular geometry, we need to see how many structural pairs we have, right? And in this case, we have 3, right? Which means our geometry is trigonal planar. And because the links between these are all bond pairs and not lone pairs, because double bonds are also counted as one, our shape is also trigonal planar. And this is important for our bond angle because electrons are always going to try to repel each other because they're like charges. They will find the farthest distance away from each other. And because there's 3 structural pairs and in this imaginary circle, there are 360 degrees. 360 divided by these 3 equals 120 as the ideal bond angle for our trigonal planar molecule.